All right, guys, this is section 2.2. We're going to talk about inductive and deductive reasoning and the difference between the two. So first we need to define them. So inductive reasoning would be to reason based on strong evidence or patterns. But it's not actual proof. Okay, we're not guessing. We're using everything we have around. We just don't have 100% proof. So think of like if you have a crime case and you don't have DNA, but there's other evidence around you and you're trying to piece it all together. That would be inductive reasoning, okay? A conjecture kind of goes with inductive reasoning, and a conjecture is just an opinion or conclusion based on inductive reasoning. So if we're looking at all this evidence, but maybe we don't have DNA, we're going to form a conjecture that maybe, this person did the crime just because of all the evidence we've accumulated and tried to put the pieces of the puzzle together. Deductive reasoning, on the other hand, is to form a conclusion based on proof or fact, okay? So this would be like, we seen someone do it and we have his DNA. You can't lie about DNA. At least I don't think you can. All right, a counterexample is an example that proves a statement false. And I feel like I should also tell you that that in order for a statement to be true, it must always be true. Okay, if a statement's true 100 times but is false one time, it is considered a false statement. All right, guys, let's look at part A. Now, I want you to think here. There's a reason I highlighted this. In the past, when we've done this lecture in class, I tell students, think about this, and we read this, and they all just look at me like, what? So I want you to take a minute, and I want you to think and try to figure it out on your own, and then we'll go over it. All right, so part A says numbers 3, 4, and 5 are called consecutive integers. Make and test a conjecture, so come up with some finding based on what we find, about the sum of any 3 consecutive integers. So we want to find it about the sum. So when I say sum, we're adding. Okay, so I'm just going to do a couple rounds. So 3 plus 4 plus 5. Those are consecutive integers. What's another set of consecutive integers? I don't know, maybe 8 plus 9 plus 10. 8, 9, and 10 are consecutive integers. And let's do something a little higher. Let's do 47, 48, and 49. Okay, so we want to find some conclusion that we're drawing about the sum of all these. Okay, well, let's find the sum. So if I add these up, what is that, 12? And this is, what, 27? 47 plus 48 plus 49, this is 144. All right, so now that I'm there, if you didn't, I'm going to stop this again, and I want you to think again, how can we get to this number without actually adding all these 3 together? All right, well, there's 2 things that we found in the past with my classes that overwhelmingly comes out when we do this. And one of them is the sum is always a multiple of 3. Okay, so it doesn't matter how many of these you do, you can do it 100 times. This sum here, it's always going to be a multiple of 3, or it's going to be divisible by 3. Okay, another thing a lot of my students notice, and this is kind of intriguing, is the sum is always the middle number times 3. Okay, so what I mean by that is 4 times 3 is 12. 9 times 3, 27. 48 times 3, 144. Those are the 2 overwhelming conjectures. If you came up with something other than that, please do share with me. Let me look at it because I'd be intrigued to know. All right, so part B, it says a student makes the following conjecture about the sum of two numbers. Find a counterexample to disprove this student's conjecture. Okay, so a counterexample. So we want one example when this is wrong, okay, when this is not true. So it says the sum of two numbers is always more than the greater number. So in other words, when we add two numbers, that sum will always be bigger than the bigger of the two that we're adding. Okay, well, find an example. All right, well, it doesn't say we have to add two positive numbers. So what if we have the sum, let's say 1 plus a -2? That's what, -1? So in this case, is the sum of the two numbers, so is -1 more than the greater number? The greater number here is 1. So is -1 bigger than 1? It absolutely is not. So this would be considered a counterexample because we prove that this is a false statement. Even if it's false only once, even if it's true, 99.9% of the time, it is false because we can find one example of when this does not work. All right, now that we've done an example, I want you guys to work this out and try to find a counterexample for these three on your own, and then we'll go over it. All right, let's go over these. Hopefully you got all three of these. All right, so A says the value of x squared is always greater than the value of x. Well, what happens if x is just 1? Now, is 1 greater than 1? No, it's equal to. So this would be a counterexample. Or what if, I don't know, 1/4 squared is 1/16? Is x squared, which is this, is 1/16, greater than 1/4? No. So there's several of these you can find. All right, part B, it says the sum of two numbers is always greater than their difference. Okay, so the sum of two numbers, so when we add two numbers, it's always going to be bigger than their difference, so when we subtract them. So what if I have -3 and 2? So -3 plus -2 is -5. And -3 minus a -2 equals, now remember when you have a minus and a minus, it becomes a plus. So -3 plus 2 is -1. All right, so is -5 greater than -1? No, it's smaller than it. So that would be a counterexample. Okay, C now, x squared equals 4 if and only if, yeah, I can't spell only, that's nice. If and only if x equals 2. Okay, so is there another time when x squared equals 4 for some x other than x equals 2? What is it when x is -2? -2 squared, isn't that a +4? So this would be a counterexample.